We will discuss basic fundamental of mathematics, which will be very useful for you all throughout your studies and later on in your professional career. In this, we will discuss the basic concepts which will keep coming again and again as you go along. Probably you must have been seeing graphs all around yourself, whether it's Google Map or map of the world. They are all present in our daily life. Every newspaper carries some graph, some representation. So we have to understand what exactly is graph. Is this white patch here Australia, or is this just a representation of a country called Australia? Are these streets shown on your Google Maps? Are the streets or the representations of the streets? This is the fundamental thing that we need to understand. Graphs are a common method to give a picture in your mind, a visual representation. If you see raw data, it's very confusing. Data we collect through experiments, even not a formal experiment, even when you are, say, witnessing a cricket match or a soccer match, mentally you are collecting data and creating mental picture. Mental picture could be which team will win. So the real purpose of this collection of data is to create a picture or to create a relationship in your mind, to understand a trend. That's why graphs are so important. We need graphs to understand the hidden relationships and to understand the trend. To draw a graph, you need Cartesian coordinate system. What it means is you need two axes, two straight lines inclined to each other at 90 degree. One is given the name x-axis, the other y-axis, and on x-axis you have certain numbering, and y-axis also has some numbers. Any point in this plane is represented by x and y coordinates. So for example, 0, 0 is the point here. 1, 0 will be this. 2, 0 will be this. 1, 1 will be this here. So that's how we create the foundation for drawing graphs. Now we come to something very interesting, and this you will be keep seeing again and again as you will go along. Relation, as the name implies, is a relationship between sets of information. For example, suppose in your class you have 5 students, Joe, Mike, Rose, Kiki and Jim, and we represent these people by numbers 1, 2, 3, 4, 5 respectively. Joe has height 6 feet, Mike 5 feet 9 inches, Rose 5 feet, Kiki 5 feet, and Jim 6 feet 6 inches. Now you can represent this in two forms. First height, then name, or name or height. These will be called ordered pairs. So you have collected data, and this data can give you some valuable information about the trends or the relationships. So we'll represent this data on Cartesian coordinate system. You have two options. One is to represent name on x-axis, height on y-axis, which is this. Other is height on x-axis, name on y-axis, which is this. Both way you are expressing the relationship. one seems to have certain more information. Let us see how. Here you see height on x-axis and the name 1, 2, 3, 4, 5, Jim, Kiki, etc. on y-axis. There's the first graph on the left. On the right, you have names on x-axis and height on y-axis. If you notice, in the first on the left side graph, on one particular height you have two students, whereas in the right side, for every person there is only one height. There is no repetition. It's obvious no student can have two heights. So which representation is better for us in certain situations? Left or right? Right one gives unique height for every name on x-axis. Left one doesn't give that. If you plot height on x-axis and name on y-axis, for one height you can have two students. This is very vitally important, and we have to decide which representation to carry forward. So in a nutshell, both graphs are relation, but height and name is not well behaved. For one height you can have two students, or three, or four. So you don't know, just looking at height, where to go. This leads us to the idea of function. For anything to be a functional relationship, on x-axis, whatever you plot is called independent variable. On y-axis, whatever you plot is called dependent variable. So if you put on x-axis the name of the person, which is then independent variable, and on y-axis the height, which is dependent variable, then it becomes function. Why? Because for every person there's only one unique height. This fact was exploited by Newton in devising his calculus also, which you will see in science. So wherever you have one unique dependent variable for every independent variable, that constitutes a function. And this relationship you see many times in phenomena around us, and that's why it becomes so important for us. For example, if you are pulling a rope, and that rope is connected through a pulley to a mass, so when you pull down, mass goes up, and when you release the rope, mass goes down. Mass doesn't go up and down simultaneously. This is what you see in nature, one unique behavior. And that's why representing input on x-axis as independent variable and output, lifting of mass, on y-axis becomes so logical for us. And that's exactly what Newton did in physics, and that's exactly what you do in biology, economics, chemistry, many places wherever you have such kind of relationship. So important thing is for you to understand how these concepts actually come alive in different subjects. So same thing in mathematical language. If there are two sets x and y, and x consists of students, say for example, and y consists of height, then mathematically the function from x to y is a relation which associates one student or one X with exactly one Y. This is logical again with the same example. A student cannot have two height. So this becomes a functional relationship. In this context, what you see on your screen are both not functions. On x-axis you have independent variable, y-axis you have dependent, and for every x you see two y, top and bottom in this graph. This x, top and bottom. Similarly on the right side, if you see 1, it is corresponding to green, but 5 corresponds to 2, red and white. So this therefore cannot be called a function. In the language of mathematics, this is also called sometimes vertical line test. If you draw a vertical line on the graph, if it cuts on 2 points, it's not a function. So many things that you will study will have this kind of behavior, especially for example in coordinate geometry, you will study circles, etc. Those are not functional relationship. Those are relationship but not functional relationship. Those are important in some areas of science. But on the right side what you see, it cuts only at one point. So this is a functional relationship. And it is very, very important in many observations which are like this, unique output for every input. For example, if a ball you release from your hand, so if you plot on x-axis time, ball will have one height at every moment. It cannot have two heights. That's why Newton chose function to develop his physics. How do we plot graph where you are given a function? So the first step obviously is you need to have the Cartesian coordinate axis. On x-axis we generally or usually plot independent variable. That is the convention we use. On the y-axis you have dependent variable. Then for every independent variable x, you find the dependent variable y and start plotting the graph. So we'll get dots, and then we connect these dots using the law of uniformity that fits these dots best. For example, you have these observations in the dots. These are, for example, for 10 you have this value of y, so you plot like this, you get these dots, and these dots are connected with best fitting line using the law of uniformity, assuming that there is no random behavior in between. That's the assumption we make, and the dots get connected. The moment dot gets connected, you start having the meaning of a slope, and which will this be discussed. So this slope also has a very significant role in understanding nature around us. For example, this is a linear graph. You have two lines, the linear one, and the slope is the angle which it makes with x-axis. For example, this angle. So we generally express the slope by the vertical length that you have gone upon the horizontal length that you traveled. So this is how actually the slope is measured. For example, the vertical change is $300, and the slope and x change, the number of passengers on our sky bus, is 10. So this length is 10 and this is $300. So The slope is $300 divided by 10, which is $30 per passenger. And you can notice that the slope in the linear graph remains constant all throughout. It doesn't change. For example, this is the slope for this, not changing. Similarly, for this, it's not changing. Whereas in a curve which is not linear, the slope changes. For example, the slope starts here, it goes on increasing. You can see that you are going more y compared to the same x if you go on the x-axis. To explain this with an example, positive slope is line slanting like this upward, and you say I have traveled from here to here, and in this I have gone this much up. If this going up was this high, that meant greater slope. So it's like climbing a mountain. If mountain is steep, the slope will be high. And slope is normally represented as symbol m. Now if this line keeps on increasing and becomes vertical, then this is undefined slope. However, zero slope you can understand if there is a horizontal road. You don't have to climb any mountain. This is an example of a zero slope. You are not going any elevation, height you are not gaining by moving on x-axis. The negative slope is when actually you go down. So for example, at this x you started with this y, but on this x you have lesser y. It has decreased from previous value. So this is the negative slope. To summarize this, there are four types of slopes. Negative, when it decreases as you go along x-axis. Positive is this, it increases as you go along x-axis. Undefined when it is vertical, and zero when it is horizontal. There is no increase in height, it is zero. Roller coaster ride is an example of changing slope. This is a curve where the slope changes from point to point, and many of the things that you will study will have this kind of a nature, where you will have a curve and the slope will be changing all throughout. We come to an important idea called domain and range. You have seen that if students were put in one set, say x, unique height corresponds, and height can be put in a different set, y. Then the set containing students like Joe, Mike, Rose, Kiki, Jim is the set x, is the independent variable, and this is called domain. And the set containing various heights like 6 feet, 5.75, etc., this is the range. And what we say is that element in x means student in x corresponds to a definite element in y, means height. And this is represented mathematically as y, which is height, is the function of x, or the student. We can also call this as image of x. This is a mathematical terms used for the same thing. So domain is set of all independent variable, and correspondingly all the dependent variable corresponding to those independent variable are called range. So this is what is expressed more clearly here, the domain and the range of the example that we took. Now if you are given a graph, on x-axis you have independent variable, y-axis you have dependent variable, then all the possible values that you see in graph, for example, x starts from here, see this point, and it ends here. So all x between here and this value will be the domain. And the range starts from here and ends here. So all these values will be the range. So you can easily read domain and range from a graph. For example, if you are given a straight line going to infinity and coming from infinity, you can see x can have any value on positive side and negative value, any negative value on negative side. So domain is from minus infinity to plus infinity. And the range, y also can go from any value in negative direction to any value in positive direction. This is the range. But if the line was restricted, say for example it started from 2, this was not there, started from 2, then the domain would be 1 to infinity and the range would be from 2 to infinity, because this portion of line is not there. This is more clearly expressed here. You see a graph and you see the minimum value achieved is 3, but it can have any x on negative side and any x on positive side. So domain is all x values, range is y greater than or equal to 3. In your studies, as you go along, you will see idea of function being repeated again and again. That's why function becomes so centrally important for all of us. Function that you will study one by one is divided into two categories, algebraical and transcendental. Some of this will come in your various grades. For example, algebraical, polynomial, rational, irrational, piecewise, and all these from smaller classes to higher postgraduate, all these will come one by one. So function therefore is very important. And why it is also very important in science, in physics, chemistry, economics, because we usually have time as independent variable, and for any time you have unique behavior, and that is your dependent variable. So we generally try to use functions to create mathematical modeling for real event such as anything varying with time.